Hey guys, today we are going to do the last new thing in Unit 2, which is to write equations of the graphs of tangent, cotangent, secant, and cosecant. So your essential question is, how do I write the equation of a tangent, cotangent, secant, or cosecant graph? So the first thing I want to make a note of is that general equation that we've been talking about this entire unit, y equals c plus a tan b, because we're going to start with a tangent equation, times the quantity x minus d. So if you remember, C is going to be that sinusoidal axis. I forgot a U. Sinusoidal axis. And those go through your center points. That's the middle of your graph. A is your amplitude. And on a tangent graph, it's kind of weird because you have those little snake things going on. And your amplitude is just from the middle to a high point. That's your amplitude. Your B is your period. It tells you about your period, but remember, period of a tangent or cotangent graph is only 180 degrees or pi radians. So when you go through and you're trying to find your period or you're trying to find your b value, you need to take pi divided by the b value or pi divided by the period. And then finally, your d value is that phase shift. And with that phase shift, it tells you your starting point. So if you can remember that tangent starts at a middle point, so in that center, and cotangent starts at an asymptote, you should be all good. So let us practice writing the equation for a graph of tangent, cotangent, or then secant, cosecant. Okay. So the first thing we need to do is we're writing the equation for each of the graphs, state the domain and range of this. So since I have a graph, I'm actually going to start by writing the domain and range. If I had an equation, I probably want to graph it before I'm looking for those values, but I'm going to start by finding my domain and my range values. So the weird thing about graphs with asymptotes is that you can actually have any x value you want except for these vertical lines. So when I write my domain, I'm going to say it could be all real numbers, any number, except for where these asymptotes lie. And the way I find those is I look for my first asymptote, which hopefully you can read your graph a little nicer than mine. My first asymptote is at 8, so I'm going to write down 8. Then I'm going to go look for my next asymptote, and that happens at 20. So 12 away from that, which is actually your period, we'll see that in a second, we're going to take that number, and then if I was to add another 12 and another 12 and another 12, that would get me more asymptotes, or subtracting 12. So I'm going to put in there. So again, when you're finding your domain, you're going to tell me where's your first asymptote, and we could have started at -4, and then you're going to add how far did it take me to get to the next asymptote and times it by a number. So any number in there. Okay, your range is actually the more straightforward one on here, because if you notice, this graph is going to go forever in either direction, up or down. So your range is all real numbers or negative infinity to infinity. So let's now try to find this equation. So again, I'm going to write down my general formula so I can find all the pieces. B x minus d. And this is in radians. So I'm going to go ahead, and my first thing I'm going to look for is that center point, or my C value. So if I look on my graph, I can see that I have an inflection point, or my graph starts to kind of turn, you know, from this weird little snake pattern right here. There's my centers. So on this guy, that's happening at 3. So my C value is 3. Okay, the next thing I'm going to look for is my amplitude value. So I'm going to find the high point that they have marked here. And I'm going to figure out the distance from the high point down to the sinusoidal axis, or that C value, which it just went up 2. So I'm going to write plus 2. Okay, I'm going to go ahead and find my period now. So a period is going to happen from asymptote to asymptote, or center to center, or high to high, whatever. You got to find the point where it starts repeating itself. So I tend to look for my asymptote to my asymptote, and then I'm going to count the distance in between here. So remember, this is 4, this is 8, so altogether my period is going to be 12. Okay, so when I'm finding my b value, you have to take your pi divided by the period, or if you're in degrees, 180 divided by the period. So right here, I would have pi divided by my period was 12. So I know that my b value is going to be pi over 12. So much like all the other ones that we wrote where we could have multiple sine or cosine graphs for every, or equations for every graph, it's the same thing here. Your a, your b, your c, well your c, your a, your b are going to be the same no matter what. What changes here is your d value depending on what type of graph you're going to write. So I'm going to try to write a tangent graph first. And tangent starts at a middle. So we're looking for middle points for my d values here. So we have a center right here at 2. We have a center right here at, who even knows what that number is, 8, 9, 10, 11, 12, 13, 14. So I can write my equation using the tangent or the letter d for 2 or for 14. Please remember that there's a minus sign built in there. So if you had a negative, if you were starting in a negative spot, you would actually add d. So my equation would be minus 2 or minus 14. Okay, so that's one of your equations that you could write. 3 plus 2 tan of pi over 12 x minus 2. Okay, much like the other ones, you are always welcome to write this as a different function, whether you're changing the d value or if you want to change this into a cotangent. So since tangent starts at a middle, we know that cotangent is going to start at an asymptote. So if I'm looking for an asymptote right here, I'd have one at -4, or I'd have one here at 8, or I'd have one at 20. So I could use any of those values in order to write a cotangent graph. Now the only thing that's different about a cotangent graph, though, if you remember from the other day, is that you start an asymptote, then you go to a high, then a middle, then a low, and so you have this shape going on. Now in order to make it look like this, where it goes from a low to a high, a low to a middle to a high, you just have to make it a negative cotangent, because all you've done here is you've reflected. So if you want to write this tangent graph or this tangent equation as a cotangent equation, all you have to do is change this sign to make it into a reflection. And your a, your b, your c are going to stay the same, and I talked all about how I was going to write a cotangent, and I wrote tan. And then the only thing that's going to change is your d. And so I go find one of those beginning values where an asymptote is, so +4, -8, or -20. So again, there are multiple correct answers for these. Find the one you're comfortable with. Let's practice doing another one. Okay, again, since I have a graph, I'm going to start with my domain and my range. So my domain here, I am going to say that this is going to have an asymptote, it's all real numbers. It has an asymptote here at pi. To get to my next, well, you know, I should probably write x not equal. I was like too excited. X not equal to pi. My next asymptote happens at 5 pi, so that's 4 pi away, times n. So you could technically, you leave it like this, pi plus 4 pi times n. Okay, again, you're looking for your starting asymptote, so your phase change, plus your period times n. Your range is all real numbers. Next part, we're going to go ahead and figure out how this graph is going to work. So write down my original function, and something that I notice here is that my graph starts at a high point. So I'm going to try to write this as a cotangent. So c plus a cotan of b x minus d. I'm going to go ahead and find all those pieces of information. So my c value, my vertical shift where my new center points are, is at 3. The amplitude from a high point down to that sinusoidal axis is 2. I'm going to use cotangent. In order to find my b, I'm going to look for my period, or I'm going to take pi, and then I'm going to look for my period. So my period, an asymptote to an asymptote, or a center to a center, goes from pi to 5 pi, so that is 4 pi. So if I simplify that down, my pi's cancel, I get 1 over 4. So my b value is 1 over 4. Here's the part where your equation can change based on what type of equation you're writing and where you feel like starting. Cotangent starts at an asymptote, so you find an asymptote and that will be your d value. So I have one here at pi, I have one at 5 pi. I have one at 9 pi, so I can use any of those. They're all positive, so I'll just write in minus pi. So one of my equations could be 3 plus 2 cotangent 1/4 x minus pi. Okay, and again, we can write this as a tangent graph as well, remembering that tangent starts at a middle. So if I was looking, my first middle point would be at 3 pi, or at 7 pi. And then remember here that tangent usually goes from a center to a high to an asymptote to a low. So it usually has that opposite snake shape. So in order to flip-flop your types here, you're going to change it into a reflection. Use your same A, B, and C, except for you're going to change the sign in between. So minus 2 tan of 1/4 times x minus any of those phase changes you found. So this answer is correct. This answer is correct. Okay, so that's tangent and cotangent. Let's quickly review how we can write it for secant and cosecant, because it's the same rules as writing a sine or a cosine graph. Okay, same deal. Since I've been given a graph, I'm going to go ahead and write my domain and my range. So for a domain, again, you can have any number in here. And the weird thing on these type of graphs is they have asymptotes. So this one doesn't have nice asymptotes listed for you, but you can imply that wherever there was a 0 on that first graph, you're going to now have asymptotes. So again, you take one of your asymptotes. That was terrible. You take one of your asymptotes, whether you want to start at 0 or 2. Then you're going to add your distance to your next asymptote, which would have been 2, and times it by n. Okay, so again, can't equal any of those values. Then your range, this one is slightly different, because remember, there's now this chunk in the middle that we can't equal, because I'm looking at only the parabolas. You notice that those middle lines are dotted for a reason. So I'm going to look on my graph and see where I didn't highlight. So my range, it went down here all the way to negative infinity. Then it stopped at -2. And it could equal a -2. That's the top of your parabola. I'm going to put union, because the set continues. Go and find that bottommost point of your top parabolas. That's at 10. And say it continues to go to infinity. So again, it's kind of the same as your domain and range, or your range of your cosine or sine graphs, except for you're going the opposite way. You can't equal. So if this is just looking at the sine or cosine graph in the middle, I would have gone from -2 to 10. So that's the domain and range. Now remember, if your graph doesn't have this original sine graph in as a guide, draw it in. You're allowed to draw it in. It's fine. That way you can kind of see, because we're pretty good at writing the sine and cosine. So let's go ahead, and if you didn't have it in there, draw it in and make sure you always put your sinusoidal axis in. Okay? So you can use sine or cosine on this. Remember, A, B, and C are always going to be the same here. So I'm going to write this, y equals C plus A, and then cosecant or secant, doesn't matter, B times x minus d. So my A, B, C are not going to change no matter what. So C is your sinusoidal axis, same deal as a tangent, and that happens in 4. It's in the middle of all of your parabolas. So my C value is 4. The amplitude, the distance from that sinusoidal axis up to the top of one of the waves or to the bottom of a parabola, is going to be 2, 4, 6. We'll pick our secant and cosecant in a second. The big thing to remember here is that the period of sine, cosine, secant, cosecant is 2 pi or 360. Remember, in order to get both of the parabolas, so an up parabola and a down parabola, or to get a full cycle of a sine or cosine graph, you have to do 2 pi or 360. So to find my B value, remember, you need an up parabola and a down parabola. So I'm going to go from here to here, because I have a down guy and an up guy. So I'm going to say the 2 pi, the whole thing, divided by how long it took me to do that. So that would have been from 0 to 4, so divide by 4, which gets me pi over 2. Okay, remember your A, B, C are the same. So now you get to decide if you're going to write a secant or a cosecant. And remember that cosecant is just 1 over sine, and sine starts at a middle point. So if I'm going to write this as a cosecant graph, then I need to look for an asymptote, because that was technically an old middle point. So when I look here, middle point going up, this would be the start of a sine graph. So for my d value for sine or for cosecant, it's going to be 2, or you could go over here to 6. So you would write cosecant of x minus 2. Okay, and again, you can write this as a secant graph as well. So if you went in here, I'm going to pick a different color that I haven't already used since I've used the whole rainbow at this point. Secant is going to be 1 over cosine. And cosine always started at a high point before. So what you're looking for, if you're looking for a high point, is you're looking for the bottom of a parabola. So if I wanted to use a cosine here, or for a secant, I would have a 3 or a 7, or you could even go backwards over here and pick -1. Okay, and so when you write your equation, it's going to be the same thing. You're going to have y equals 4 plus 6, now secant instead, pi over 2, and then you're going to have your new d value, which would be 3. Okay, and that is all I've got for you today. That is writing equations of all of those other trig functions. Have a great night.